So very good morning to all. Today we'll see the solution of differential equations using Laplace transform. So in the last video, I have given in detail how to take the inverse Laplace transform using partial fraction expansion. That is, we are expecting three types of roots for the system. It can be distinct, it can be repeated roots, or it can be roots can even be complex. So for all those things, we have seen separate methods to how to find the residues of such roots, and we have easily solved uh, uh, the we have easily found the inverse Laplace transform given the ROC of the system. So today we'll see how to solve a differential equation. Having learned such that much, it's very easy to solve a differential equation. So one of the greatest advantage of Laplace transform is solution of differential equation. You have learned differential equations a paper in third semester, and you might have seen how it was difficult. Not that difficult, but somehow we have to apply methods so that you can solve differential equations. Particularly, it's a solution of two things, the addition of two things, that is complementary function plus particular solution. So you have to separately find the complementary function, separately find the particular solution, and then add those two things to get the differential equation. So than that method, this method is very simple. You can account the initial conditions, everything you can do. You can find the transfer function, and the greatest advantage of Laplace transform is that you're not taking you're not keeping the differential equations as such. Rather, you're converting the differential equation in the form of simple algebra, that is in the form of simple addition and subtraction. Addition and subtraction, whenever you see an addition and subtraction, you'll get a feel free attitude. So that is the greatest advantage of a Laplace transform. So having said that much, we'll see in detail how that differential equations are being solved using Laplace transform. You can see on the screen, that is total response. There are two methods. That is, one method you might have learned in the mathematics course, that is complementary function plus particular solution. Another method of solution, of finding solution to this differential equation, is that finding the response to, that is following the superposition principle. That is, um, first you give the that is you find the response of a system to the uh, initial conditions. So system may have in some initial condition, maybe a capacitor may have some stored voltage, or an inductor can have a stored current in its magnetic field. So there will be some storage elements which may have some initial values. So what is the response of the system to that initial values? That is called the zero state response. So at that time, you'll consider the response only due to the initial conditions, and um, then actually then you apply the actual input, that is called the forcing function. You apply the actual input, then when you consider the actual input, you never consider the initial conditions. That is what is superposition principle, that is one at a time. So you find the response of a system to due to the forcing function or the actual input. Okay, so we have got two outputs or two responses. One is due to the initial conditions alone, and the other is due to the actual input alone. Okay, then you add. Okay, then you get the total response, and that is what is written at the top. That is, total response is called natural response plus forced response. Natural response is due to the initial conditions, and forced response is due to the actual input. So that is another thing. That is another way of finding solution to differential equations. So differential equations take the form that is given there. Okay, so LHS is of the order of n, and RHS is of the order m. Okay, and the initial conditions, if you neglect it, why initial conditions are neglected there? If you are asked to find the transfer function of a system, then initial conditions are neglected, because transfer function is defined that like that, because you might have learned in linear control systems, that is definition of Laplace, definition of a transfer function. For a transfer function, you never consider initial conditions. So whenever asked to find a transfer function, you have to neglect initial conditions. That is why initial conditions are neglected. If initial conditions are neglected, you can actually write that equation in the form of y of s by x of s, which is written at the um, bottom. Okay, then you will see some examples. Very simple to find the transfer function of a system if y of t is equal to u of t plus e raised to minus t u of t minus e raised to minus 3t u of t minus e raised to minus 4t u of t, and the actual input is x of t is equal to e raised to minus 2t ut. So you find the Laplace transform of input as well as the response. So when you take the Laplace transform of the response, that is y of t, it becomes y of s, and for input from it transforms from x of t to x of s. So what is x of s? E raised to minus 2t is well known, that is it is 1 by s plus 2. And when you take the Laplace transform of the output, y of s is equal to u of t, the Laplace transform is 1 by s, e raised to minus t u of t, it is 1 by s plus 1. The minus is already there, the other one is 1 by s plus 3, and the other one is minus 1 by s plus 4. You substitute everything, find the ratio of y of s by x of s, you'll get such a value. So that is a transfer function of a system. Okay, likewise you can see the bottom two problems also. It's very easy. um, that is, whenever transfer function is asked, no need to consider the initial conditions. Okay, and example 9.59, that is solve the integral differential equation. Why it's called an integral differential equations? Because you have differential terms as well as integral terms. Okay, and there you have okay, there also you don't have initial values are specified, but initial value is 0. So taking the Laplace transform of both sides, so what you get is s into y of s minus y of 0 plus 2y of s. Okay, when you 2y of s, then plus 5y of s by s, that is the Laplace transform of an integral. You might have seen that in when you take the Laplace transform across the voltage drop across a capacitor. Okay, so not voltage drop, the current through, yeah, voltage drop across a capacitor, and that is equal to 1 by s plus 2, because the Laplace transform of e raised to minus 2t is 1 by s plus 2. Again, you solve those. You have to the question is to find the solution means y of t, you have to find y of t. So you'll get the y of s as s by s plus 2 into s plus 1 the whole square plus 2 square. Okay, s square plus 2, 2s plus 5 can be written as s plus 1 the whole square plus 2 square. So these are the some techniques you have to know. Okay, then you have to write the in the form of partial fraction a by s plus 2 plus bs plus c divided by s square plus 2s plus 5. Then you have to find the residues a, b, and c, solve substitute that and find the inverse Laplace transform. Okay, so you'll get the result as, okay, what is the inverse Laplace transform of 1 by s plus 2? That is e raised to minus 2t u of t. Minus 2 by 5 is already there. Then again plus 2 by 5 will come outside. What is the other thing? E raised to minus t. Then it is in the form of cos. That is cos 2t u of t. The other one is 3 by 10 e raised to minus t sine 2t ut. Okay. Now in the example 9.6, so what's the difference? Initial conditions are given. Okay, so you solve that to find the transfer function, neglect the okay, you are asked to find the transfer function. If so, even though initial conditions are given, you have to neglect that. That is the crux of that. Same method you can see there also. Then here in example 9.6, when a system is described by the differential equation given by that, and you have to find the impulse response of the system, that is one thing. So what is impulse response? So in the previous problems you have seen certain inputs like a x of t is equal to u of t, x of t is equal to e raised to minus 2t u of t, such things. Okay, but if you want to find the impulse response, then the input of the system should be definitely an impulse. So x of t should be equal to delta of t. So whenever you give input as delta of t, you'll get a response, and that response is called the impulse response. So here, whenever you are asked to find the impulse response, definitely your input should be delta of t. So, and initial conditions are given for the second case. Okay, we'll see what is that. So you have the differential equations. Then so taking the Laplace transform and neglecting the initial conditions. Okay, so whenever the impulse response is taken, initial conditions has to be taken as 0. That is another point. So for transfer function as well as impulse response. Why for impulse response transfer initial conditions are neglected? Because impulse response if a is h of t. So whenever you take the Laplace transform of h of t, you'll get h of s. What is h of s? H of s is nothing but the transfer function. So y of s by x of s is nothing but h of s. H of s is called the Laplace transform. So h of s, when you take the inverse Laplace transform, you'll get the h of t. H of t is nothing but the impulse response. So whenever you're asked to find the transfer function as well as the impulse response, initial conditions should be made 0 or they have to be neglected. That is the thing or the point you have to keep in mind. So here also you take that very easy, and x of s is there, and h of s is nothing but the transfer function h of s of the system is y of s by x of s, and you'll get it as 1 by s square plus 5 square plus 6, and you can resolve that, that is 1 by s plus 2 into s plus 3. Then for impulse response, x of t is equal to delta of t. So what is the Laplace transform of delta of t? It is learned that x of s is equal to 1. You that is y of s is equal to h of s into x of s. You are actually finding the impulse response, that is y of s. You have to find y of t. So to find y of t, you have to find y of s first. So y of s is equal to h of s into x of s. So x of s is 1, that is equal to h of s is itself, that is 1 by s plus 2 minus 1 by s plus 3. There they have resolved they have found the partial fraction, that is a by s plus 2 plus b by s plus 3. They have found a is equal to 1 and b is equal to minus 1 there substituted. Then they are taking the inverse Laplace transform. So inverse Laplace transform of h of s is h of t. So h of t is nothing but e raised to minus 2t u of t minus e raised to minus 3 u of t. Now in the second condition, what is the second problem? For the initial conditions given, and your input is x of t is equal to u of t. So when you have given x of t as delta of t, it was called the impulse response. So when you give the input as step, then that is called, the response is called step response. So when you give input as delta of t, it is impulse response. The output of the system or the response is impulse response. Likewise, when you give the input as u of t or the step function, then the output will be, the response will be called as a step response. So indirectly it is given, that is x of t is equal to, directly it is given as x of t is equal to u of t. So indirectly what it means is that you are asked to find the step response. So taking the Laplace transform, the same question itself. So since initial conditions are given, you have to take that also. So that is x s square into y of s minus s into y of 0 minus minus uh, first derivative of y of 0 minus. That is the full scale expansion Laplace transform of d square dt square of y of t, and plus 5 into sy of s minus y of 0 minus plus 6 into y of s, that is equal to x of s. Okay, so grouping, and y of s is, y of 0 minus is given as 1, and d by dt of y of 0 minus is nothing but 2. Substituting everything and regrouping, you'll get it as the y of s given there. So x of s is nothing but 1 by s there. Okay, you can simply do it and see. You just see one or two problems and understand that, and then you take a book, take your notebook, write down the question and do it yourself. Then only you'll understand. Okay, you may commit mistakes, but that is okay. The material is there, you can find the correct answer also. So x of s is 1 by s, Laplace transform of u of t is 1 by s. Substitute that and uh, find y of s. So you will get such an equation there. Then you can find the expansion using Laplace transform and take the inverse Laplace transform, and you can see that that is Okay, that is, for the first two terms are due to the natural response, and the last three terms are due to the forced response. So total response you can combine and see what it gets. Okay, so that is another important problem, and that is given just for a mentioning, that is what is natural response and what is forced response. Forced response is only due to the input. So whatever response is due to the input, that is called the forced response, and whatever response is due to the natural response, that is called the initial condition, that is called the natural response. You to sum total everything, you could get the final answer, and that is very important. Okay, and then the forced response I told, that is not due to the initial conditions, that is only due to uh, the input, actual input. So here the actual input is x of t is equal to e raised to minus t u of t. Substitute that, find the residues. You can see that answer is 1 by 2 by s plus 1 plus 1 by 2 s plus 3 minus 1 by s plus 2. So uh, there actually we have added the input itself is a pole, and that pole is at s is equal to minus 1, and that is what the first term is called, the pole due to input, and the other two terms are due to the system itself, that is the poles of the system. Okay, and that is what is written there. Okay, so when you take the inverse Laplace transform, you'll get it as half e raised to minus t. So that is the input itself, and then that is due to the input pole, or it is called the steady state response, and the other two poles contribute to transient conditions, or that is called the transient response. Okay, or you can tell that response is of two types, that is due to the steady state response, and the other due to the transient state response. So what is steady state response? The response of a system due to the input only, and the other is the input of the output of the system due to, or the response of the system due to the system poles. Okay, and the other things, the example 9.63, you can just understand, do it and understand. Okay, and example 9.64 also you can do it and understand. Okay, it's very simple, everything is given clearly and you can understand. Okay, and finally I just want to tell this. Okay, already I have mentioned what is impulse response and step response. You can just go through that. For impulse response, only thing is that x of t is equal to delta of t. After substituting at that, you have to find y of s, and taking the inverse Laplace transform, you can find what is y of t. Likewise, for step response also the same things. Okay, so here also I have given around 10 problems. Solve yourselves and see, these are straight away 10 mark questions. So then only you will understand, because taking an online classes has its own limitations, and I know it is not worthwhile to take or just scroll these problems through a screen and make you understand. It's very difficult, so you have to do itself. Okay, and try to do all, every materials are given, you can try to do it yourself, then only you get the understanding of such questions. Okay, so, and one more last point I have to make is that there is a sentence itself in your syllabus. What is the relation with causality and Laplace transform? See causality, you know what is causality. So from Laplace transform, or from after finding the Laplace transform and seeing the ROC itself, you can tell whether that's a causal system or a causal system or not. That is, uh, for a signal, if that is for a signal, if it is a causal, you are applying as you are finding the Laplace transform, and you get that, you see that an ROC, you see an ROC. If the ROC is to the right side of the right side of the pole, okay, I'll take this in another instant, or I'll just mention that in a note. Okay, because I have to project that using a problem there, so I'll give the material for that. Okay, so go through these problems, do these problems by yourself in the notebook. Thank you.